A ball is thrown straight up in the air with a velocity of 63.7 meters per second. So let's start with a diagram. We've got a little illustration of a ball going up into the air. So we can see what we have and what we know. We know the initial velocity is 63.7. It's positive and the direction is up, meaning anything down will be negative. So what do we know? We know the initial velocity is 63.7 meters per second. We know that once it leaves our hands, it's under the influence of gravity at 10 meters per second squared downward. Because it's in the opposite direction, it has the opposite sign, negative. The problem tells us that it's 3 seconds, that the interval we're looking at is 3 seconds. Therefore, the unknown is the velocity, because it says what is the velocity after those 3 seconds. Looking at those 4 variables, we know the best equation is the VOTAT, v equals v naught plus a times t. It's already set up for final velocity, so we can just plug in our information, 63.7 plus negative 10 times 3. Our final answer should be 33.7 meters per second. What is its position after 3 seconds? Now, instead of looking at final velocity, it's looking at delta y. We call it delta y because it's moving vertically, not horizontally. Now, I'm going to intentionally not use the final velocity that I calculated in problem 1a, because what if I made a mistake? I don't want to introduce that mistake in 1b. So again, I'm going to write out the things I know. 63.7 meters per second is the initial velocity up, acceleration negative 10 meters per second squared down, time is 3. I'm looking for delta y. Yes, the problem's writing delta x. It's just a nasty habit I have. But let's keep it with delta y or delta x, whatever. With the information I have, I can just use the delta y equals v naught t plus 1/2 at squared. 63.7 times 3 plus 1/2 times negative 10 times 9. Looks like my answer is going to be 191.3 minus, let's see, minus 45. It'll be 146.1 meters. The next question, how long does it take, it's talking about time, how long does it take the ball to reach its maximum height? Well, if the initial velocity is 63.7 meters per second, it's under the influence of gravity in the opposite direction, so opposite sign, acceleration is negative 10 meters per second square. At the maximum height, we know the final velocity is 0. That's where it changes directions. It's no longer going up. That makes it the maximum height. Now we're looking for time. Again, this is our VOTAT equation, v equals v naught plus a times t. And if we rearrange that equation, which is the best idea, we would get v minus v naught divided by a to solve for time. V is 0. 0 minus 63.7 divided by negative 10 should give us 6.37. And the unit of time is seconds. What is the maximum height of the ball? Again, the initial velocity is 63.7 meters per second upwards. Acceleration's in the opposite direction, so negative 10 meters per second square. At the maximum height of the ball, final velocity is 0. The maximum height of the ball, we're looking for displacement, so ideally delta y. In this case, we've got no time. So v squared is equal to v naught squared plus 2a delta y. If we solve this for delta y, we would get v squared minus v naught squared divided by 2a. So 0 squared minus 63.7 squared divided by 2 times negative 10. So the 63.7 squared, that's not a negative 63.7. You're actually subtracting a positive 63.7. So at the top you'll have a negative number, the bottom you'll have a negative number. And then when you do the math, you get 202.88 meters. What is the ball's speed when it is at an elevation of 100 meters? The initial velocity is still 63.7 meters. Acceleration, gravity, opposite direction, negative 10 meters per second square. Delta y is 100 meters. And we're looking for final velocity, so v equals question mark. What formula has everything besides time? The one we just used. We have v squared is equal to v naught squared plus 2a delta y. And we're solving for v, so I'll just leave this one alone. There's no reason to get nasty and square root the right. Just to demonstrate the rearrangement, I'm just going to go ahead and put it in with the way I have it. 63.7 squared plus 2 times negative 10 times 100. Don't forget, when you solve for that right side, it's still equal to v squared and not equal to v. Once we solve that right side, we will need to square root. Looks like I have v squared is equal to 2057.69. I'll need to square root that, and my units will be meters per second. Next question says, when is the ball at 100 meters? So my initial velocity is 63.7 meters per second. Acceleration, negative 10 meters per second square. Delta y is 100 meters. And when is the ball? Time is question mark. Our formula of choice would be delta y equals v naught t plus 1/2 at squared. But we're looking for time, and now we've got t and t squared. This is not the math that I'm wanting to do. So this is when I'm going to actually then utilize an answer that I've gained previously in the problem. What if we go ahead and grab the final velocity from the 100 meter mark and utilize it? So the answer from E, utilize it in F. We're taking a risk, but I think it's going to come out better for us because now we can use our favorite equation. Or no, we can't use VOTAT. Yeah, we could use VOTAT. We could totally use VOTAT because we've got V naught, we've got A, we've got V, and we're looking for T. So let's use that previous answer, take a risk, put a little faith in ourselves, only when necessary. And we've got V is equal to V naught plus A times T. So V minus V naught divided by A is T. (45.36) minus 63.7 divided by negative 10. Looks like we get 1.834 seconds, the unit of time being seconds. Brings us down to G. When will the ball be at its initial position? If the ball moves upwards with an initial velocity of 63.7 meters per second, at its highest point, the velocity is 0. Then when it comes back down, it reaches its initial position. Since it had the same acceleration as upwards as it did downwards, we should expect the same velocity at the same position, just in the opposite direction. That is, our final velocity would be same magnitude, opposite direction, negative 63.7 meters per second. Acceleration is still down. Acceleration is negative 10 meters per second square. And then when will the ball? So it's looking for time. In the previous problem, we've already solved and rearranged the VOTAT equation for time. So we know that time is going to be equal to V minus V naught divided by A. That's simply just a rearrangement of the VOTAT equation. VOTAT equation being V equals V naught plus A times T. So we've got negative 63.7 minus 63.7 divided by negative 10. like 1.274, something like that. Or 12.74. Yeah, 12.74 seconds. Okay, number 2. What maximum height will be reached by a stone thrown straight up with an initial speed of 35 meters per second? V naught is 35 meters per second. Final velocity be 0 because we're talking about its highest point. Acceleration's in the opposite direction, downward, so negative 10 meters per second square. And we're looking for delta y. This will be the no t equation, so v squared is equal to v naught squared plus 2a delta y. If we rearrange, we'll have v squared minus v naught squared divided by 2a is equal to delta y. Just simply subtracting the v squared to the other side and then dividing the 2a to the other side. So 0 squared minus 35 squared divided by negative 20, because 2 times negative 10. (61.25 meters). Best answer matching up to multiple choice is D, 62 meters. Number 3, a ball is dropped. If something's dropped, the initial velocity is 0 meters per second. Now, the initial direction is downward. We're calling everything downward positive for this question, so acceleration is positive 10 meters per second square. Hits the ground with a speed of 49 meters per second, so final velocity is 49 meters per second, and we want to know the height. Now, if you choose downward to be negative, you'll need to make sure that your acceleration is negative, your final velocity is negative, and your displacement must come out to be negative. I'm choosing positive because since it's only going down, I'm going to make the downward the positive direction. You can make that distinguish. You can choose that for whatever problem you're working on. So it looks like we have our equation. V squared is equal to v naught squared plus 2a delta y. Rearrange it. Delta y is v squared minus v naught squared divided by 2a. Plugging in the information that we have, 49 squared minus 0 squared divided by 2 times 10, or 120.04 meters. Number 4, a boy is standing at the base of a tree. In the tree are some friends throwing water balloons full of hot sauce at him. Well, that's pretty mean. That's not a pretty scene. Our hero wants to hit one of them, if not all of them, so those so-called friends with a baseball, preferably in the face. That's a pretty rough situation. He also wants to throw the ball to be hit. He wants the ball to hit them at 5 meters per second when it finally reaches them. If his friends are 32 meters above the point of release of the ball, how fast must the boy throw it? So I've got my tree, got a kid in the tree, kid on the base of the tree, got a ball going up. We know we want the final velocity to be 5 meters per second. It will be moving up, so we're going to call up positive. Gravity is going to be going down. Well, if up is positive, down is negative, so acceleration is negative 10 meters per second square. We know the delta y is 32 meters, and we're going to solve for initial velocity. I think this is another one that's a v squared is equal to v naught squared plus 2a delta y. We only have 4 variables we're dealing with, so the equation can only have those 4 variables, nothing more. We're solving for initial velocity, so we can just say v squared minus 2a delta y is equal to v naught squared. At least gets the v naught by itself. And plug in things we know. We've got 5 squared minus 2 times negative 10 times 32. And when we solve the left side of that equation, don't forget the right side is equal to v naught squared. So we'll have to calculate the left side, and then we'll have to square root so that we can get v naught. (665) is equal to v naught squared. Square root of 665 is 25.79 meters per second. All right, same boy. Now blind due to the hot sauce that got in his eyes. Turns out he wasn't any good at throwing the baseball. Is practicing throwing straight up as much as he can. On one particular occasion, he decides to throw very close to the edge of a cliff. He throws the ball straight up with an initial velocity of 20 meters per second. So the initial direction and velocity is upwards and positive, 20 meters per second. And on its way down, it passes its initial position and lands on the ground 30 meters below the cliff and his initial position. So the initial velocity is 20. It's going up. And it's going to go up and around and back down way below him. Now that I've got my picture all situated, so I've got a visual of all of this, I know exactly what's going on. Don't even have to go back and read the paragraph. In number 5a, what is the velocity of the ball when it is at the level of the cliff? So if it goes up at 20 meters per second, when it comes back down at that same level, it's going negative 20 meters per second. Or we can call it 20 meters per second downward. There's a strategy for doing that, so just bear with me. Looks like we've got a second 5a. Find the velocity of the ball just before it hits the ground. Well, let's reset our question. Let's say it's starting at the cliff and going down. We can say down is positive, couldn't we? I mean, we're able to do that, aren't we? And it's starting at 20 meters per second downward. Acceleration is 10 meters per second downward. And the displacement is 30 meters. If you want downward to be negative, you need to say the initial velocity is negative 20 meters per second. Acceleration is negative 10 meters per second square. And the displacement delta y is negative 30 meters. You've got to make a choice. I made down positive. If you want down negative, all of those values are negative. We're looking for final velocity. Looks like the same equation as before. V squared is equal to V naught squared plus 2a delta y. By writing these each and every time, you get to learn them. You don't have to look them up and waste valuable testing time. We're just going to plug in our values. We're looking for v. It's set up for v squared, so when we solve the right side, we're just going to remember to square root. Looks like on the right we have 20 squared plus 2 times 10 times 30. Is that v squared is equal to 1,000? So square root of 1,000. .62 meters per second for that final velocity. How long does it take for the ball to fall? All right, it's a little ominous on this question. They're not very specific. So we're going to say, when they say ball to fall, we're going to use the same path that they're talking about in the previous question. So not from the time it took to go up to the highest point, not from the highest point down, but from the point it reached its initial height down. So how long did it take to fall those 30 meters from the child's height down to the cliff? So we're just going to say the cliff edge down to the ground, that 30 meters. The initial velocity is 20 meters per second because we're calling down positive. No reason to do otherwise because it's only going one direction, so let's just make that direction positive. Acceleration is also downward. We've said downward's positive, so acceleration will be positive 10. Delta y, positive 30. Here we're looking for time. So our best equation, would that be the delta y is equal to v naught t plus 1/2 at squared? Well, I would use this one if v naught was 0, but now I've got another issue of having the t and the t squared. So I guess I'm going to have to go on faith again that I know what that final velocity is at 31.2 meters per second. Let's go ahead and take the risk, make the math a little bit easier. So now we've got v naught, v, a, and we're looking for t. We get to use VOTAT. It's always beautiful to use the one with the name. So if we're going to rearrange the VOTAT equation, v equals v naught plus a times t, it is v minus v naught divided by a is equal to t. Just a rearrangement, a little algebra with the variables. We said that v is 31.62. We're going to subtract v naught, 20, and we're going to divide by the acceleration of 10. So we get what, 11.62 divided by 10. So 1.162 seconds. Yeah, looks good. What is the maximum height of the ball as measured from the top of the cliff? So now we're talking about the first part of the trajectory. So we're going to reset. We're talking about him throwing up, and it hit his maximum height. Well, he threw up with a velocity of 20, so up is now positive. Let's reset that drawing so we know exactly what we're looking at. We're only talking about the going up. So now if up is positive, 20 meters per second, up is positive from the child up to the sky. Final velocity is 0 because that's where it changes direction. Acceleration is in the opposite direction, so now it has to be negative. If you've been down negative the whole time, this question for me and for you are exactly the same. Up is positive, down is negative. Delta y, let's see, is our question mark. So v squared is equal to v naught squared plus 2a delta y. V squared minus v naught squared divided by 2a is delta y. Just rearranging. 0 squared minus 20 squared divided by 2 times negative 10. I get 20 meters. Use the following to answer questions 6 through 8. A ball is shot straight up from the surface of the earth with an initial speed of 19.6 meters per second. So there's my ball, there's earth. It's going to go up with a v naught of 19.6. It says neglect any effects due to air resistance, but honestly in our course, we'll only address air resistance if it's a part of the problem. We'll never assume that it is. Now, we're smart people, so we know that there's something other than just the v naught. We know our acceleration's in the opposite direction. Well, if velocity positive is up, it has to be negative when it's down, and the acceleration of gravity is negative 10 meters per second. Number 6 says, what is the magnitude of the ball's displacement from the starting point after 1 second has elapsed? So we know time is 1 second plus the stuff on the left side, the initial velocity and acceleration. We're looking for delta y. Our best formula should be delta y is equal to v naught t plus 1/2 at squared. I can keep this formula because I know time. I don't have to worry about t and t squared. I can plug them in. So v naught is 19.6 times time is 1 plus 1/2 times negative 10 times 1 squared. So 19.6 minus 5. So I get 14.6. Best possible answer, 14.7 meters. Let's just be used to finding the closest multiple choice answer based on our math. What maximum height will the ball reach? Well, we know that means that we're looking for delta y, but final velocity is 0 because that's where it's changing direction. It's never going to go further up. If once the velocity goes to 0, it's going to change direction. We have delta y, we have final velocity, initial velocity, and acceleration. So v squared is equal to v naught squared plus 2a delta y. A little bit of rearrangement. V squared minus v naught squared divided by 2a is delta y. Now it's just up to us to plug in the math. 0 squared minus 19.6 squared divided by 2 times negative 10. Yeah, I'm not going to do the 19.6 in my head, so we're just going to have to see how the calculator comes out and then pick the closest answer to our calculation from the multiple choice. Looks like we're getting C, 19.2 meters to something. All right, number 8. How much time elapsed between throwing the ball to the return of its original launch point? Well, if we know the original velocity going up is 19.6, when it comes back down to the same point, the final velocity needs to be negative 19.6. The acceleration is negative 10 meters per second square. And we're looking for time. So our Votat equation, rearrange the Votat equation, we get V minus V naught over A is equal to T. That comes from V is equal to V naught plus AT. So we get, plugging in negative 19.6 minus 19.6 minus 10 is T. And then once we do the calculation, we're just going to match it up in 3.92 seconds. Best answer is A, 4.